Terraforming is the process of intentionally modifying the environment of a planet, moon, or other body to simulate Earth's atmosphere, temperature, surface topography, and ecology to make it inhabitable for humans. It is a concept that evolved from both actual science and science fiction, with Carl Sagan being one of the first proponents of planetary engineering. While many celestial bodies have been considered for terraforming, Mars is regarded as the most likely candidate. However, the feasibility of creating an unconstrained planetary environment that resembles Earth remains uncertain. The subject has sparked debates on practicality, methodology, ethics, logistics, and economics. Despite this, research on various forms of terraforming, such as biological terraforming and paraterraforming, continues. Carl Sagan once proposed seeding Venus's atmosphere with algae to reduce the greenhouse effect, but later discoveries made this approach impossible. Venus's highly concentrated sulfuric acid clouds posed a significant obstacle to terraforming. The theme of terraforming is a fascinating one that has garnered significant attention in recent years. In March 1979, NASA engineer and author James Oberg organized the first terraforming colloquium, which fueled interest in the concept of creating habitable environments on other planets. Oberg's book New Earths, 1981, further popularized terraforming, and in 1982 the word was officially used in the title of a published journal article by planetologist Christopher McKay. In the years since, scholars like James Lovelock, Michael Allaby, and Martin J. Falk have contributed their own ideas and definitions to the field of terraforming. Falk, in particular, has proposed clear definitions for planetary engineering, geoengineering, and different stages of terraforming. Ultimately, the goal of terraforming is to create open planetary ecosystems that can support human life. As research continues, it is clear that microbial life will be a key component in the initial stages of creating sustainable ecosystems on other planets. The story centers around the concept of an easily terraformable planet, ETP, meaning a planetary body that can be rendered biocompatible or habitable with modest planetary engineering techniques and limited resources. The notion of planetary habitability is crucial to this concept and involves meeting various geophysical, geochemical, and astrophysical criteria. Terraforming is the hypothetical process of modifying a planetary surface to sustain life. Particularly for humans, of particular interest is the set of factors that have sustained complex, multicellular animals in addition to simpler organisms on Earth. The classifications of habitability criteria can vary. However, it is generally agreed that the presence of water, non-extreme temperatures, and an energy source are essential. The habitable zone is the region in which stable surface liquid water may be present on a planetary body. These constraints apply primarily to Earth-like planets and may not be applicable to icy moons like Europa and Enceladus. It is crucial to the hypothetical process of terraforming that these constraints are met if humans and other living organisms are to sustain life on other planets. The story focuses on the possibility of terraforming Mars and the elements necessary for life to exist. 6 elements, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, are considered essential for all known life, while other cations and anions are also crucial. The loss of Mars' Earth-like environment occurred due to 3 potential mechanisms: the reaction of surface water with rocks, the lack of a magnetosphere, and asteroid impacts to transform Mars into a habitable planet that could support animal life. 2 significant changes would need to occur: building a thicker atmosphere composed of greenhouse gases and heating it. To achieve this, specialized greenhouse molecules would need to be created. The theme of the story revolves around the possibilities of terraforming Venus and Mercury. While Venus is believed to have a flawed understanding of its atmosphere with an untenable idea of injecting floating bacteria to increase oxygen concentration, an additional step to inject water and/or hydrogen into the atmosphere has been suggested. The difficulty level of terraforming Mercury is also discussed, with the idea of enhancing its magnetic field by placing an artificial magnetic shield at Mercury's Sun L1. Despite being smaller in size, Mercury can hold a nitrogen/oxygen atmosphere for millions of years. The suggestion to deliver 3.5 by 10^17 kilograms of water and covering Mercury with a thin layer of doped titanium dioxide photocatalyst dust holds the possibility of a breathable atmosphere and allows plant growth in the presence of nitrates. The possibility of terraforming other planets or moons has been explored by scientists, with the Moon being one potential candidate. Despite its low gravity, it has been suggested that a 1 psi atmosphere of pure oxygen could be created through various methods, such as extracting oxygen from lunar rocks or using water from comets. Similarly, other celestial bodies such as Jupiter and Saturn's moons and the dwarf planet Ceres have been considered for partial or para-terraforming. The development of synthetic biology has provided scientists with a toolkit for genetically engineering organisms that could potentially create Earth-like conditions on other planets. However, the biggest hurdle is the ability to tailor microbial genes specifically for the chosen environment. Nevertheless, the prospect of terraforming offers a potential solution to the effects of climate change and the desire to explore and possibly inhabit other worlds. The concept of para-terraforming, or the world house, involves encasing a planet's usable area in a habitable enclosure with a transparent roof held above the surface by tension towers and cables. Some propose genetic engineering, biotechnology, and cybernetic enhancements instead of or in addition to terraforming. While some argue that terraforming other worlds is necessary for human survival and continuation, others question whether it is ethical to interfere with existing planetary ecologies. The cost of such projects would be massive, and economic strategies are not yet incorporated in most proposed models. National pride and politics have historically influenced space projects and would likely also impact planetary terraforming efforts.